Good afternoon, everybody. Welcome to the Squared Up Coffee Break. Today we are talking about tuning the SCOM Data Warehouse. My name is Matthew Long, and I'm joined this week by Richard Benwell.
Good afternoon, Matthew.
Richard's returned to the coffee breaks after a bit of an absence. He's been all over the world, traveling around, but he's back to show us how to make the data warehouse really fly in your SCOM environment. So, Rich, what are we looking at?
Thanks, Matthew. Well, I guess we wanted to talk about the data warehouse today. It's something that comes up on support a fair bit, and we see a really wide range of data warehouse sort of performance within our kind of customer environment. So we have customers where the data warehouse absolutely flies, and of course, Squared Up looks fantastic with that performance. If you haven't seen it, the case study we do with Purdue University is a good example of that. Over, I think it is 1,800 servers, and they can just browse around every dashboard with a lot of performance data on those dashboards, and it's just instant or near instant. And on the other end of the scale, we have customers who struggle perhaps generating some smaller graphs, even in some smaller environments. And then there's obviously a big sort of disparity between the performance of data warehouses across those environments. So what we wanted to do is just recap, I guess, on some best practices, sort of level set a bit, hopefully, so that those of you who do have data warehouses that are working very nicely, please do share any other tips and advice. And those who maybe are struggling to kind of get the expected performance out of it, hopefully can consume the advice we've got here today. So we'll cover a quick recap of the SCOM and Squared Up architecture. How does the data warehouse actually come into play? Then we'll look at data warehouse tuning tips, and I've structured that as a 5-point plan that we'll sort of come on to in a second. And throughout that, we've got a bunch of useful resources and SQL queries. So a little bit of links, hyperlinking off to useful resources out there, and a little bit of hands-on SQL queries, so you can kind of get to see what's in your data warehouse and how it's performing.
Cool.
So first up, what I wanted to do is just cover quickly at a very high level. This is not a particularly deep dive architecture slide, but just at a high level how SCOM and Squared Up work together. Obviously, we have all of the agents that are collecting all of that data. So performance data, event data, obviously monitor state changes and so on. And we know that then gets collected by your management servers. And typically you have a pool of those servers. Ultimately, though, those servers are just running services, and that data gets dumped into your ops DB. So all that data is ending up in the ops DB. And obviously we know that then flows out through into the ops console. Now, back in 2007 days, so SCOM 2007, this was a minimal setup, right? You didn't have to have the data warehouse, and hence the ops console was sort of fully functional on top of the ops DB, including all of your performance data as well. And then I think in 2012, they made the data warehouse a mandatory component of the deployment. So during the install of SCOM 2012, you had to deploy a data warehouse. Now, the really interesting thing about that orange arrow here is that with 2012, the introduction of 2012, all of your performance data and your event data and your monitor state changes were being written into the data warehouse simultaneously. So all of that performance data, for example, that's collected from the agents actually gets written in real time to both the ops DB and the data warehouse. There's no job that's transferring it from the ops DB to the data warehouse, which I think was the common perception, that the data warehouse was some sort of long-term storage where overnight the data would be backed up to the data warehouse. Actually, the SCOM architecture works a little differently and writes into the data warehouse sort of simultaneously. So, for example, your raw performance data is in both databases. There is no data in the ops DB that isn't in the data warehouse when it comes to performance data. Now, with just the SCOM consoles in the picture, you would then typically have that reporting console, or SSRS. Didn't get a lot of use, so you had a lot of orange. You had a lot of data going into the data warehouse, and not a lot of yellow, right? You wouldn't often be reporting out of the data warehouse. So your data warehouse was sitting there, kind of unloved to some extent. So it was storing all that data, and then it was aggregating that data and storing it for a long term. But that data was generally not seeing the light of day. Yeah,
with 2012, they changed it, didn't they? So you had a different view type in the SCOM console that would read performance data from the data warehouse as well, which created that lovely dichotomy where some views would show you ops DB data and some would show you data warehouse data, and customers often would be confused about why am I seeing different values.
Yeah, and I think that's more of a recent development, that the ops console, some of the management packs have started to introduce views that pull the data from the data warehouse. But really, Squared Up was, I think, one of the first UIs on top of SCOM that recognized that performance data was being written simultaneously into the data warehouse, and hence, rather than try and pull it out through the SCOM SDK, you put it out from the data warehouse directly using the published schema. So that's the picture with Squared Up, consuming that data. So we consume data from the ops DB and directly from the data warehouse. From the OpsDB, that's all of your core runtime data. So obviously we are still authenticating through the SCOM SDK. So your users and role-based access control is all defined by the OpsDB. All of your entities, so your SCOM objects, your servers, your disks, and so on is read out of the OpsDB. All of your class information, so your management pack information, your monitors and their health, all of the alerts and the current state as well. So on the left there, I put the icons showing if you're using health state in Squared Up, whether that's on a Visio tile or just the status icon, that's all coming out of the OpsDB, as are the alerts. So that's your sort of bread and butter. That's your sort of kind of core SCOM data. But the data warehouse we then leverage for performance data, state history, and I'll come on to that in a second, and event data in theory if you're pulling that out via the SQL tile. But it's the performance data that's the key one. So all of the performance data comes out of the data warehouse. So despite SCOM storing it in the OpsDB and the Ops console showing it from the OpsDB, we never pull performance data out via the SCOM SDK from the OpsDB. It all comes from the data warehouse. So anywhere where performance data appears on Squared Up, that's coming from the data warehouse, and your data warehouse performance is key. Actually, you're related to a question that I've seen already come in. When it comes to reporting on SLAs, so the SLA gauge, that comes from there is no table that represents SLA data in SCOM. That's just reporting against the state history tables in the data warehouse. So the data warehouse is storing the state of every single monitored entity in your environment, both in terms of the raw changes and then hourly and daily changes as well. So that's what we sit on top of to generate those SLA gauges as well in the Squared Up product. So performance data and SLA data all derived from the data warehouse.
And I guess that's also true for dynamic table as well. So any tile that shows a performance-based information, whether that's a performance tile directly or indirectly, comes from the data warehouse.
So the 5-point plan. So as I say, performance data, I think, is one of the most valuable aspects of SCOM, on top of obviously the obvious health state and the dashboards and alerts. And actually what we hear a lot of is some amazing feedback around being able to get to that performance data through Squared Up. So you put Squared Up on top of your SCOM environment, and suddenly server owners can just search for their server name and C:, drill down into free disk space report, see that over a year, and then export that into Excel all in a matter of a few seconds. So it really is, I think, the crown jewels of SCOM, all that performance data, and certainly from your user's point of view, that's really what they're primarily interested in, is being able to get to all that data. And of course, it's sort of fundamental then that the data warehouse is tuned. So I've got 5 points that I'm going to cover in the coffee break, and actually what we'll see is reading the data back out, the Squared Up bit is perhaps the least of your concerns, and if you actually get all the other bits right, then building your dashboards becomes a breeze. So we're going to look at, first of all, sizing. So that's obviously a pretty fundamental consideration when you're looking at data warehouse performance. Configuration of the actual SQL servers and the databases themselves, and then we're going to be breaking down actually what's happening at runtime by looking at the data that's going in. They're the orange arrows that we saw in that previous diagram, so data being written into the data warehouse. Then we'll look at storing the data in the data warehouse, so that's data retention, so how long is that data stored for, how much data is stored, and then looking finally at getting the data out, which is where Squared Up is reading it and putting it onto your dashboards. So let's get started with sizing. Now, I could glibly just point you towards the Microsoft sizing guidelines for the data warehouse, right? And I'm sure everyone's done that and kind of looked at that when they first started to install SCOM. But what I want to do is really sort of lay out how I see sizing working in the real world, which is typically you start somewhere, right? You start with a particular service of sizing and sort of SAN sizing, and then you sort of want to check, well, is it fast enough, right? So sitting on top of our current data warehouse, is that good enough for me? And typically that's going to be looking at Squared Up performance if you're building dashboards on top of that data warehouse. If it's not fast enough, then we need to optimize it. And that's what we'll look at in some of the next slides. How do we optimize and make the most of the resources, the hardware resources that we currently have? Once we've done our optimizing, what we really want to do then is show our business the potential of having better performance, right? There's no point in going to the person who holds the credit card and saying, well, we just need, we need more resources here, right? We need more resources for the data warehouse, if you can't show the value of having those extra resources. So optimize as much as you can, get the best sort of value out of what you currently have, then show the potential of having better data warehouse performance through Squared Up dashboards. Ask for more hardware on the basis that wouldn't it be great if we had these dashboards but they were running much faster, Hopefully that request gets approved. Brilliant. You up the size of your storage or your SQL server, and then you can run through that again and kind of make sure that you're getting the most out of it. Now, I guess if your request doesn't get approved, you've got to go back then and probably demonstrate the value of having that better hardware and those greater resources, right? So go back and kind of make sure that people are really clear on what having a really fast data warehouse would mean to them in terms of the capabilities of performance reporting and dashboarding.
Yep. Maybe I even look at like the use cases that you're actually targeting and see are they the right use cases. Like you made a valid point, but actually the business doesn't care about what you're trying to show.
And then in the rare case that it actually really is fast enough, then job done, but probably you'll always be looking for further extra performance. So that's sizing. That's kind of all I wanted to say there. Obviously start with the Microsoft sizing guidelines, but the real focus is the optimization piece and then showing the value of getting more hardware. Whenever customers come in via support to us and say, hey, like this dashboard's running a bit slow, we're trying to show this performance data, but it's not fast enough. The last thing we do is say, we'll go get more resources for your SQL server. We'll go through the optimized steps first and then sort of make sure that they are clear on the sort of potential that they can have if they get more sort of resources, and then obviously provide that with the evidence they need to take to their business. So it's the optimized step that we wanted to focus on today. In terms of configuration, Matthew, this is an area we all know more than me. Based on actually feedback from Sean Williams at Purdue, who had a great live case study of where his environment really flies, he came back to us and said, well, there are two resources that I followed, and I'm pretty sure that if everyone follows those same resources, they'll get just as good performance. So the first one is really around configuring your SCOM and SQL server setup. So if you are or have the opportunity to set up a new SQL server or get your DBAs to deploy out a new database for you, this is the guide that you need to follow. Yes. And Matthew, can you explain why there's kind of the two guides there?
Yeah, sure. So the guides were actually written by a group of MVPs, and Paul Keeley was the primary author on both of these guides. And what he did effectively with the first one, which was written up in 2012, just came out, was cover over configuring SQL and deploying it for the first time. And he talks to a lot of the optimizations that you can do at your actual SQL instance level. So, configuring disks correctly, configuring the appropriate settings for SCOM specifically, things like that. The second guide then, basically it builds on the first one and says, well, this is all the stuff that's still true, but now we have to think about SQL always on. We have to think about sort of cloud-hosted resources like putting VMs in Azure, things like that. So rather than sort of double the length of the guide, he's kind of broken them out and said, well, this is the first one that you read if you're like having on-prem SQL servers, you're starting up for the first time. And then the second one is more sort of the updated workflows that you might be building these days. What I would say is that if your environment's already sort of built and configured, the first guide probably has more things that you can retroactively change to try and like tweak the environment and get more performance out of it. If you've already deployed the thing, the second guide won't really help because it's more targeted at, like I said, modern workflows, like you're deploying it brand new SQL cluster using storage spaces on Azure. So if you're not in that sort of realm, the first guide isn't necessarily as relevant.
Oh, actually, on the second guide then is similar to that sort of tuning guide once you've got it deployed. A real, I think, goldmine of resources for SCOM, both the sort of SQL and data warehouse performance as well as SCOM performance in general. It's this ebook. It's actually a little bit hard to track down, hence the quite sort of lengthy URL there. I found the URL that was still live, but it's written by I think a bunch of Microsoft Premier field engineers, where they've pulled all of their resources together based on their experiences with customers and put that into an ebook. And it's pretty awesome actually. It goes down into some quite hidden registry keys that you wouldn't know about unless you read that ebook. And those are registry keys that allow you to tune the SCOM behavior, so the agent behavior and the management server behavior. So really worth scanning through that and just sort of picking out some tuning tips and applying those in your environment. So that's a kind of great ebook to download and browse through. Now, once you've got it set up, obviously you then want to make sure that configuration stays sort of valid and optimized. And for this, we'd recommend using Tao Yang's community resources. He built I think a PowerShell script that does a data warehouse health check. So there's a download there on our support site. And he also authors and maintains this self-maintenance management pack. So that actually creates a set of monitors that are going to be checking your SQL configuration and alerting you if anything has fallen out of shape.
And for those of you with the Catalog MP, that management pack is in the community catalog as well, so you can download it straight from there.
So that's getting your configuration right. And again, either you have a chance to deploy out some new SQL infrastructure for SCOM, or at least sort of check through some of those tuning tips to kind of make sure that you've enabled all of the best practice configuration. So that's the configuration slide. And then I want to look at data in. I think this is the more interesting aspect of the data warehouse, because when you look closely, there's a lot of data that gets pushed into the data warehouse, and not all of it is equal. Not all of it gets used. So common sources of high load, I'd really recommend taking a look at this in your own environment, no matter how good you think your data warehouse performance is. I'd recommend kind of looking at these sources. The first one is flip-flopping monitors. So every health state change on any object, so for any monitor in your environment, is stored both in the OpsDB and the data warehouse. So you can have a huge amount of changes being written into the data warehouse. The sort of go-to resource for this is Kevin Holman, of course, and there's the link there. I'll open that up, and then I'm going to run this query live in our environment. Let's just...
While you're bringing that up, I actually have an anecdote from my previous days as a consultant. I went into one customer where their whole environment was completely paralyzed. All the aggregation jobs were failing, and no performance was getting updated. And it turns out that a flip-flopping monitor that was generating 1.5 million state changes every 24 hours, which doesn't sound necessarily that bad until you realize that because it was very low down in the dependency monitoring chain, every single monitor above it was also flip-flopping the same number of times.
Roll-ups. Yep. So really, yes, by reducing change down in your environment, obviously then you're just focusing on the information that is valuable, which is the sort of the monitors that you do need to know about. Typically, what flip-flopping monitors is to do with thresholds not being tuned appropriately. I think actually Kevin lists here as well, it being about agents sort of going up and down and coming on offline and online and so on. So this is the query. You run that against your OpsDB. So I'm just going to fire up SQL Server Management Studio here. So I was logged on as the wrong user there. So this is the domain user. So if I run that against my OpsDB, you can see the results here. So this is the number of state changes per monitor across all of my servers. And you can see here topping the charts. Well, whereas if we get below the top 10, it's down to 50, 100, right? So it tails off very, very quickly, down to very few state changes. At the top here, we have a monitor that's changed 18,000 times, right? And this is across, I guess, what's the retention period for monitor state changes? 10 days, 14 days? Yeah. So over the last sort of week or so, we've had 18,000 changes of this monitor. And you can see the disproportionate sort of load that's putting on our databases, both the OpsDB and the data warehouse. Now, that's an example where typically we wouldn't want 18,000 alerts coming out of that, or 9,000, however many it is. So we'd want to kind of look at that and tune it down. I actually literally ran this before we came on to the coffee break today, and you can see that's coming from the security monitoring management pack that we talked about in a previous coffee break. So actually that's checking for repeated logons. I think we have a bunch of Azure machines that get absolutely hammered with some logon requests. So that's an example where that we probably want to review that monitor now and perhaps either disable it for those machines, or change the threshold such that we're only being alerted more occasionally. So that's a good example, I guess, for both alert tuning and for your database and SCOM performance to tune that down. And I'd probably look at that and this one here where we've got CPU. So that's nearly 3,000 state changes. So again, I'd probably kind of look at those two and tune those down and assume the rest are more reasonable. So that's definitely worth doing, I think, regularly. Good sort of point here is that we installed that management pack, I think, in the last few weeks. It was a new management pack. We're very pleased with the results. But actually having now rerun these queries, we can see that perhaps we need to sort of tune that, and we wouldn't have had evidence of needing to tune that unless we'd run these queries.
Exactly. The rest of the SCOMs seem to be performing fine. It's just the data warehouse performance that's suffering.
So that's monitors. And then when I actually originally showed off some of these resources in kind of recent training session, I realized there wasn't actually the equivalent queries for performance data. And actually, if you think about it, performance data is being collected all the time, not when just there's a state change, but actually, for example, CPU is being collected all the time across all servers. So I put together a quick query here that is going to query for, how do I copy and paste that? It's going to query against the performance table. And I've got one more here, which is the same for the event data as well. So let's just switch back to SQL Server Management Studio. So I've got the query here, which is for the performance data. So this is looking at my raw performance data in the data warehouse. And let's just execute that query. Takes a little while. Now, I think what's worth pointing out is the numbers here are vastly higher than those state changes. So you can see how much activity is going through your data warehouse. So, even sort of the 50th rule down here is writing 36,000, and that's 36,000 data points that are going into your data warehouse. There's a lot of data going in. At the top here, 160,000, so dwarfs the kind of 18,000 we just saw for the state changes. We've got 160,000 data points going in. Now, ironically, this is the agent CPU usage. So perhaps one of the last metrics you might, your users might look at, right? You might be looking at it, but that's, I think, the default collection interval set up in the SCOM management pack. So actually, out of the box, you're putting a lot of load on your data warehouse, a lot of data going into your data warehouse just because of this default rule that's looking at the agent CPU.
In fact, if you even look at the top 15 of those, 1 to 13 are basically coming from 3 management packs.
Yes, yeah.
Agent collection.
Yeah, and of course it's weighing up whether it offers much value. So actually looking at the agent CPU, no, that's not worth being the most collected performance metric in my environment. Maybe my Hyper-Vs, maybe that is more important, and I'm happy to collect that if it's being consumed on dashboards all the time. Yep. Same with my web applications, to be honest. If that's kind of key dashboard information, then I might want to collect that, and then sort of we can run down and see SQL and so on.
But I think it's very telling if you scroll up again, if you look at some of these counters, say the web application tests, got 10,000 for each of those values, and it starts to drop off dramatically. 100,000 very quickly drops off. Yep. That's probably not because of the amount of web application monitors we're doing. It's just that probably the resolution's down to something silly like check every 10 seconds.
Yeah. Yeah, so check the targeting and the resolutions.
Yeah. Likewise, the ones above, they're all sort of CPU memory performance counters that are coming from a Hyper-V management pack, and yet we're also collecting those anyway using the Windows operating system management pack. So maybe that's got a much higher resolution. That's set to do every 10 seconds, but we're also collecting 5 minutes. That's a disparate intervals. Which one's right?
Yep.
Or maybe we disable the other one so we're not collecting duplicate data.
Yeah. So the rule is not to take the top one and turn it off. The rule is to probably look at the top 10 or so, and then really actually understand what they're doing and what the value they have. This is another interesting one, and I literally wrote this query before I came on air because I was interested in the event data as well. So a very similar query. We're looking at the event view in the data warehouse here, and then just looking at it by rule. I don't even know what that number is. 1.7 million. 1.7 million events coming in, and again from the security monitoring MP. So that's the failed logon attempt. So again, a management pack we'd installed recently, we probably wouldn't have necessarily noticed a sort of a huge change directly in terms of the performance of the data warehouse, but actually we've now got a huge amount of data being written in, and that seems a very easy win to tune that down, either to suppress that entirely or retarget that. PowerShell module, is that your stuff, Matthew, with the PowerShell MP?
No, that's not me.
So who knows? But you can see again what the top 2 really dominate there. Maybe the top 3, and the rest it kind of tails off very quickly. Now, one thing we'll see in a second is event data, unlike performance data, where performance data is really just one number and a timestamp. Event data can be very large, right? Because you're pulling, for example, a full event log entry out of your event log and putting it into the SCOM data warehouse. So that's looking at data in.
So one other thing I guess you can also look at is for some of the performance collection rules, there is does your query take optimizers into account as well or not? Because there's a feature in SCOM, and it's not configured for all management packs, that basically says if the performance collection sample is very similar to the previous value, don't bother logging it, just assume it's very similar. So I guess if you've got some rules that again are very errant, you're looking at it and saying, well, actually we need this data, check to see if it is using the optimized performance collection rule, because if it's not, you could always disable it and then re-implement it using that and set an appropriate threshold.
Yep. So we've looked at sizing our data warehouse. We've looked at configuring it correctly, and now regularly probably looking at the data that's going in and just tuning that down. The next step is to look at how long we're storing that data for. Now, probably all know that the data warehouse stores data in 3 forms. It's the raw data, so typically for, I think, 14 days.
The raw, yeah.
The raw data, yeah. And then the hourly data, so every hour, the data warehouse runs an aggregation job and then stores in a separate table the sort of hourly aggregate, so the min, max, average, and standard deviation for each hour. And then it does the same every midnight for the daily data as well. And you can see here that actually the hourly data can become huge, which is not necessarily the sort of what you guess at instinctively. You think, oh, it's probably the raw data that's taking up all of the space in the data warehouse. And I'll show you in a second how we can prove that hourly data. Now, the two problems with storing all of that data for such a long time, one is the large storage requirement.
Yep.
Typically not a massive issue, right? In terms of you just say, oh, I need half a terabyte, that can be available. And again, if you can argue the cost there. The problem really that relates to today's topic is that you end up getting very, very large data sets in your data warehouse. Now, just a query that suddenly then is not scoped to a particular time frame can start pulling all of that data off disk and filling up your SQL memory buffers. So the fact that you just have these very large data sets, if they're on disk and they're never read off disk, fine, that's just a disk cost. But often they do then come into memory, and so you hit the I/O and the memory limits there as well. So recommendation, again, it's that man, Kevin Holman. Let's just click on this link here. So he runs through a very nicely explained blog post as usual, and he relies on this tool called DW Mart. Where is it? It's just this DW data rp.exe. That came out of Microsoft a few years ago now. So I've downloaded that, and I'm just going to show you the results. So I'm going to run it here, and essentially what it's going to do.
So you run this on your data warehouse server?
Yeah. So it looks, hopefully we can see that. It looks at your data usage in your data warehouse, and then it works out the percentage of storage used by that particular data set. Let me just see if I can make this a little bit larger here.
Not it. There you go.
Okay, it's still a bit unreadable, but the points here is the hourly data is taking up 23%, nearly a quarter of all of our data warehouse storage, as opposed to, say, the raw data, which is taking up barely anything, 2%, right? And the daily data, well, that's only kind of 1%. And I think it's the fact that sort of the multiples get a lot larger. So we've got 400 days worth of 24-hour, whereas here we've got just 24 days. So you can see approximately got 24 times as much daily data as hourly data.
And likewise, the raw is very high resolution, but we're only keeping it for 10 days. So
so 23% is the hourly performance, and typically we go back to our customers and say, think about that 400 number. Do you want hourly data records for over a year, or is it okay to be then looking at sort of trending, over a daily period when you start reporting across a whole year? So that can often be chewed down to, say, sort of 6 month, or just above a quarterly threshold to something around sort of three or 4 months, and you can make big savings in your storage requirements there. Same with the state data. So the hourly aggregations for state data, again, a fifth or over the sort of fifth of our data warehouse storage used for that. And then, interestingly, in our environment, you see there's really nothing else that consumes it apart from the event data. And actually, that comes back. That's why I wrote that data in query for event data. It's like, wow, half of all of our data in the data warehouse is event data, and we never use that.
No, exactly. Data. Typically, SCOM operators don't use the event data. It's one of the most underused features.
And again, so that's a combination of sort of untuned collection rules, so event collection rules, and combined with the fact that event data is quite large data. So rather than a single data point, it's typically a large XML blob that's taken from your event log. So that's going to be something that we're going to be looking at in our lab, tuning down and trying to get that down to sort of a reasonable amount.
It's funny that in comparison to all of those, everything else is like 0%, isn't it?
Yep. So again, I would recommend running some of these tools on a regular basis and just kind of making sure you're on top of what's in your data warehouse, and kind of tuning those retention thresholds.
I guess it's also worth doing that after alert storms as well, because that may have introduced a large amount of data into your environment that you're now going to keep for 400 days. It's going to affect performance for all that time as well.
So the last slide is actually just around data out. And after you've done the sizing and the configuration and you've looked at the data going in and the retention periods, typically data out then becomes the easy bit. So when using performance tile, all we'd say is just carefully choose the aggregation. We say this in the UI. So reporting against raw data is going to be a little bit slow, because if you report, I don't know, over the past 24 hours against raw data, that's a lot of data points. Whereas if you switch to hourly, that's going to be just 24 data points. So hourly is a lot faster, and daily is the fastest, especially for top-end reports.
Right.
So if you're trying to do a lowest disk space across all of my computers, do it against the hourly data. You obviously don't need raw, typically, data for disk space reports. So especially when using the bar chart with a top-end option, really you always use hourly or daily, unless it's really, really important that you're doing it near real time. And then again, if you get anywhere near sort of 100 objects, then switch to hourly and daily data. Typically, though, that's all that we advise when actually building your dashboard. So scope it appropriately and use the correct sort of aggregate where appropriate. Otherwise, if you've done the other 4 points, typically you shouldn't come across problems. And as I say, the case study from Purdue University is a really good example of that. Those dashboards are fairly heavy with performance data, but they load in just a few seconds.
I do have one tip for the on the bar chart front from STS. Adam has found, actually through testing with a lot of customers, that if you want to display the current value, which is quite actually fairly typical, and you don't care about ordering, so you're not doing top end, you're just saying show me the current value, Sparklines is faster than the bar chart. That's what he says, and that's what customers have found too. So yeah, you just want to show the current value, have a really nice narrow Sparklines tile. It's got a nice big number that says currently CPU is at 50, whatever. There you go.
Okay, worth experimenting then between those different options.
Yep.
And then the last tip I want to talk about, or I guess explanation, because we get asked this a lot on support, which is can you increase the timeout? So you'll find that if you do have slow dashboards, it will sit there for sort of 30 seconds and then time out and say, well, it's error retrieving the data from the data warehouse. The timeout is not configurable. And that surprises a lot of customers when they come in and say, can we increase it from 30 to 60 seconds? There's a few reasons. My favorite reason is that in a dashboard, no one wants to wait 30 seconds anyway. So there's not much point in increasing it to 60 seconds because you will just then have users using that dashboard, not waiting for 60 seconds, browsing away or refreshing, so suddenly you're hammering your database because you've got users being impatient. So there's not much point in extending it beyond 30 seconds in a user interface that users are expecting to see responses in a few seconds. That's kind of one of my favorite reasons. But the real reason is that if queries are taking really anywhere near 30 seconds, certainly if they're timing out after 30 seconds, the query is not working. And there's just no point in extending the timeouts. When we sort of have experimented with that, typically all you find out is that query takes 3 minutes because it's so broken, because it's not using an index on the data warehouse, or your data warehouse is having a problem. So extending that timeout really offers no value. Really all queries, especially around Squared Up, all queries should be coming back in a matter of seconds, every sort of single query. So if it is timing out after 30 seconds, then we'd go back to saying, well, let's look at the query, either actually optimizing the query or scoping the dashboard more appropriately, or let's have a look at your data warehouse and kind of make sure that we've tuned it appropriately.
And I guess going back to your comment on if it takes 3 or 4 minutes to run and users' expectations, if you're trying to crunch a data set, if you genuinely want to show CPU for 1,000 servers for 400 days, that kind of use case is probably some sort of auditing or like quarterly report. Use the SCOM reporting features for that. Pre-calculate that value and send it to everyone. Don't try and do it on an on-demand dashboard.
Yep. So that's what I had. That's sort of, as I wanted to structure it. I'm just going to go back to that previous slide. I hope you don't mind, Matthew, and then we can kind of recap. Just on the 5-point plan. So sizing, configuration, data in, data retention, data out. If you already deployed out your data warehouse, then the sizing configuration, the horse is bolted there potentially, right? You've already got what you've got. But I would recommend, anyone sort of on this webinar just thinking, I'm going to run some of those queries around looking at the data going in, because I may surprise myself, and use that retention tool just to report on what data. Again, we ran this, we're surprised about that security MP. We still sort of thoroughly recommend it. It just needs tuning, and I think Nathan Gow does highlight the fact that
he came on the coffee break like 3 weeks ago and did say you need to tune the thing.
So go take a look at that, tune it down, and then you're always going to get benefits, whether it's less storage or faster performance out of your data. Your Squared Up dashboards.
Yep. Likewise, because this data is being written to both databases, probably if you disable some of the rules or tune them appropriately, you'll find your SCOM SDK will get faster as well.
Yeah, very true. I mean, less data going through the management servers, right?
Yeah.
It's just less load on the management servers. So if you're not uploading that data from the first place from the agent, it's kind of less load all around.
Yep.
All right, I'll hand back over to you, Matthew, for the resources.
Cool. Thank you very much for joining us, guys. I know we've gone a little bit long today. If you have a suggestion for a topic that you think that we should cover on the coffee breaks, please go to our coffee break topic survey at squareup.com/topics, where we have a whole list of topics that we think would be helpful. But there's a free comment field at the end where you can suggest your own topic. So if there's something you've always wanted to know or something you've been struggling with recently, go fill that form out. Let us know, and we'll love to hear the feedback and adjust our schedule and make sure we try and talk about that topic. You can go and see what's coming up next on our Coffee Break microsite at squareup.com/coffee break series. There's also a sign up form there. So if you've got a colleague or a friend who you think, they'd love this stuff, you can get them to go to that page and sign up, put the details in, and we'll go to webinar link. The recordings and slides are published via our blog, along with a wealth of other great content. So if you've been looking at the queries, desperately trying to screenshot before Richard changes slide, go to squareup.com/blog, and you can get the slide deck there with all the queries and links in. And there's also a YouTube playlist for this series as well. So you can go there and watch, it's over like 2 or 3 days worth of content by now on Squared Up, enterprise monitoring, SCOM, and we've got case studies. So we keep mentioning Sean at Purdue, like how fast this environment is. If you don't believe us, how fast SCOM can be, go and watch that video and you can see him just go, oh look, bam, there's a year's data immediately. So it's definitely worth checking that stuff out. There's lots of good videos there. Now, as always, the engineering team are online, as well as myself and Richard. So if you've got questions, please feel free to enter those into the webinar chat and we'll do our best to answer those. If not, thank you very much for joining us. Thank you, Richard.
Thank you, Matthew.
And have a great day, guys.